Hi, this is Kaylee, and with this episode, we're going to talk about solving problems with waves. And before we get into it, we've got just really have two equations that we're going to focus on today. Velocity equals wavelength times frequency, and period is the inverse of frequency. And so, again, period is the time for one wave to pass in seconds. Frequency is how many waves pass every second, and that has a variety of things that we can use. We can call it hertz, 1/seconds, or inverse seconds. Wavelength uses the Greek letter lambda. It's the distance between two consecutive identical parts of a wave. So from crest to crest or from trough to trough, it's measured in meters. Amplitude is the height of a wave, and that's from the midpoint up to a crest or from midpoint down to a trough. Not the entire height from mid up or from mid to the trough. That's measured in meters. Sometimes we can do it in centimeters, that's okay. Wave speed, how fast the wave's traveling through that medium, and that's in meters per second. And let's take a look at our first problem. Let's start off very basic with just identifying the difference between period and frequency. I found that this is one place where a lot of students have trouble, and one of the main sources of issue if they're having trouble solving these problems. So let's look at this statement. 20 waves pass each second. Okay, so 20 waves, it tells you how many waves pass every second. So since it's telling you how many, that is a frequency. So the frequency is 20 hertz. Now the period would be 1 over the frequency. So that'd be 1/20. So the period is 0.05 seconds. Now, if we take that same number, but we rephrase it a little bit. On this one, a wave passes every 20 seconds. So for this one, it's telling about a wave, like a single wave takes this long to go by. So since it's telling you how long, that is a period. The period is 20 seconds. And that means if we want to find the frequency, super secret metric is what I call it when you swap these two up. So the frequency will be 0.05 hertz for that. See, it's the same math, it's just how the statement's read. If it tells you how many, it's a frequency. If it tells you how long, it's a period. All right? Now, let's get into some more calculations. We've got a transverse wave, has a wavelength of 0.75 meters and a frequency of 4 hertz. And we want to find the period and the speed. So I've got the wavelength is 75 or 0.75 meters. The frequency is 4 hertz. And I want to find the period and the speed. Well, it doesn't matter which one I do first. Let's go ahead and find period first. So period is 1 over the frequency. So that'll be 1/4. So the period would be 0.25 seconds. No problem there. Now for wave speed, velocity equals wavelength times frequency. Wavelength is 0.75. Frequency is 4. And so my velocity should be 3. So it's moving at 3 meters per second. And that's it. That's all you have to do for that one. Let's change things up so we have to solve for something else. So on this one, we got a water wave has a speed of 6 meters per second and a wavelength of 30 meters, and we want to know the period of the wave. Okay, so we got the velocity is 6 meters per second. Wavelength is 30 meters. And we want to know the period of the wave, so we're looking for period. Okay, well, we have one problem here, one little issue. We're looking for period. And we know period is 1 over the frequency. So that really means I also need to find frequency in order to use that equation right there. So let's start off with our wave equation. Velocity is 6, wavelength's 30, and we got to find frequency. So 6 divided by 30 gives me 0.2. So my frequency is 0.2 hertz. Now I can use that to find the period. 1 divided by 0.2. So I want to take the inverse of that. We get 5 seconds. So it takes 5 seconds for a wave to pass. Let's take a look at a graphical one. Let's say we were giving these two graphs and we were asked to find these 5 things about this. Now both these graphs represent the same wave. This graph is measuring a distance, while this graph is measuring a time, but they both represent the same wave. So the first thing is find wavelength. Well, wavelength is a distance, so I'm going to use this one. And wavelength is the length of just one wave. One wave will be one complete crest and one complete trough. And so in this case, that's 5, 10, 15, 20. That would be 20 meters. Amplitude. If I look at this, oh, I've got the same amplitude on which, remember, amplitude's from the midpoint up to a crest or midpoint down to the trough. Well, either case, that's 2 centimeters. If we want to change it to meters, that's okay. But we can just leave it as 2 centimeters for right now. Oh, I don't need wavelength here. That's not what I need. I actually need period. There we go. Period, which is capital T. So period, we measure it sort of like wavelength, where we want to know for just one wave. But in this case, we're looking for period, we're looking for time. So I wouldn't use this graph, I'll use this one because this one's measuring time. And I've got several waves here. There's one wave, 2 waves, and half of another. So I've got 2.5 waves drawn here. But I only need to know the time for one wave. So if I start here at a node getting ready to go up, I'm going to go to another node getting ready to go up. So that would be half, 1, 1.5, 2, 2 seconds. Or if I did from crest to crest, 0.5, 1, 1.5, 2, 2.5. So I went from 0.5 to 2.5. So that's a difference of, again, 2 seconds. Either way is okay. Just remember, you got to measure from corresponding parts of the wave from one to the next, from one to the identical next one, from one to the identical next one. But they all should be the same. So my period is 2 seconds because I only measure one wave. Frequency, well, that's where we're going to have to do some math. Period is 1 over the frequency. So we got 2 equals 1 over F. Super secret metric. Frequency comes out. The 2 takes its place. So my frequency is 0.5 hertz. Now to find the speed or velocity, velocity or speed is equal to wavelength times frequency. So I take my wavelength from there, which is 20, my frequency from here, which is 0.5, and I get a velocity of 10 meters per second is my velocity. So that's going to be 10 meters per second. Right. So this is how you can get information from a graph in order to answer those questions. One more question for us. This one is still a wave, but this one's light. Now the one thing about light is light travels the speed of light, which the speed of light is 3 times 10 to the 8th meters per second in a vacuum. And so I want to know the frequency and period of this beam of yellow light. Well, we can use velocity equals wavelength times frequency. Now, sometimes since we're talking about electromagnetic radiation, light, X-rays, gamma rays, any of those things, we rewrite this to use the speed of light. So it becomes C equals wavelength times frequency. It's still the same equation, still the same math, but now we know that's a constant, and it's that number right there. We are given a wavelength of 5.8 times 10 to the minus 7 meters. Now, sometimes it's written like that, or sometimes they can give you 580 nanometers, or written out in scientific notation, it's 580 times 10 to the negative 9, which if we put it back into that form, it becomes 5.8 times 10 to the negative 7. All of these represent the same number, just different styles of writing it. So now that we know this, I'm looking for frequency and the period. So C equals wavelength times frequency. Again, that's velocity. 3 times 10 to the 8th equals 5.8 times 10 to the minus 7. So I want to divide 3 times 10 to the 8th divided by 5.8 times 10 to the negative 7. And I get a frequency of 5.17 times 10 to the 14th power hertz. So that would be my frequency. Period will be 1 over that frequency. So it'll be 1 over 5.17 times 10 to the 14th. Well, actually, let's do it this way. 5.17 times 10 to the 14th. Take the inverse of that. I get 1.93 times 10 to the minus 15 seconds. So that means one wave goes by every 1.93 times 10 to the negative 15 seconds. So a very, very short amount of time. Thank you very much, and tune in for another episode of Waves later on. Bye.